In this video, I'll be showing you how to use the Simpson's 1/3 rule to numerically integrate a function. Before we proceed, I recommend that you copy these tables down here, just so that it becomes easier if you want to input values or formulas throughout the video, or you can also download this Excel file which I've shared in the description below. Here we're asked to find the integral of the function 5 plus 3 cos x, and we're asked to integrate from the point 0 to the point 5. Now the formula here is given. Now you might notice that we have three different tables, and these tables correspond to different step sizes. So we have delta equals 2.5, delta equals 0.5, and delta equals 0.1. In hindsight, they just mean that we're integrating at more points. And I'll get to that as we go along the video and why it's important to do so. But for now, let's just utilize the Simpson's 1/3 rule just so that you have an understanding of how the formula works. Right, so in the formula, we need three different points. We need a point of f of x minus 1, a point of f of x, and a point f of x plus 1, which are simply evaluations of the function at different points. And so even though we're integrating from 0 to 5, we need point 0, point 2.5, and point 5. And evaluating simply means taking the original function and replacing the x with our x's. So it's simply just 5 plus 3 times cos x, and x in this case is 0. Now we repeat the same steps for the values below. So it becomes the following: 5 plus 3 times cos 2.5 and 5 plus 3 times cos 5. And once we get that, we can get the integral of the function, which is simply just utilizing the formula here. And the formula is 5 minus 0 multiplied by f of x minus 1, which is this, plus 4 times f of x plus f of x plus 1. And we close bracket and divide that by 6. There. And we successfully used the Simpson's 1/3 rule to find the value of the integral. Now, if you use a calculator, you'll find that the analytical or exact value of this integration is 22.123. However, with our approximation using the Simpson's 1/3 rule, we found that the value of the integral is 20.1977. This indicates a 9% error. And this is why it's important to use a smaller step size or to integrate at multiple points. So let's try to do the same thing again, but with smaller step sizes. So let's evaluate the functions at all these points, and for this you can just simply copy down the formula you've made previously and just highlight it all and paste it here. And again, what we're doing is simply just evaluating the function at this point, at this point, at this point, and so on and so forth. Now what you need to do is utilize the Simpson's 1/3 rule. And so in this case, we're going to be integrating from 0 to 1 first, and then afterwards from 1 to 2, and then from 2 to 3, 3 to 4, and then finally 4 to 5. And from each of those integrations, we're going to take the sum, and that will be the final value. So let's do that right now. So first we have to integrate our point from point 0 to 1. So 1 minus 0 multiplied by 8 plus 4 times 7.63 plus 6.621, close bracket, divided by 6. And again, this is just the Simpson's 1/3 formula. Press enter and copy down these formulas up to this cell, like this. And notice that these cells are merged, meaning look, they're not one individual cell, and this is one of the more important steps you have to take when utilizing this formula in Excel, because in this case you can just copy down the formula instead of having to do it one by one. So as you can see here, the formula first starts with the integration of 0 to 1, and then when you copy it down, it goes from 2 to 1, and then from 3 to 2, and then 4 to 3, and eventually 5 to 4. With that, we've found the value of the integral, which in this case is 22.122. And our exact value is 22.123, Our approximation with the Simpson's one-third rule is 22.122, and this indicates an error of 0.0036, which is much smaller than our previous error, right? And this highlights the importance of using a smaller step size. Now let's try it again, but with an even smaller step size in this case. So let's try a step size of 0.1. Let's copy the formulas again, highlight them to the bottom like this, and let's take the integral formula, copy it down here, and let's see what we get. Okay, now utilizing the step size of 0.1, we've got the value of the integral to be 22.123, and our approximation, our exact value from the calculator is 22.123 as well. And this indicates only a 0.001% error, which is even smaller than the previous step size. And this is why it's important that if you want to use the Simpson 1/3 rule, it's much recommended that you use a smaller step size instead of integrating right away from 0 to 5, as the answer you get is much closer to the actual or analytical value. And this is just a graph to show what we're doing, basically. And so this is the curve of 5 plus 3 cos x. And when we use the Simpson's 1/3 rule, we're trying to find the area under the curve here. And this area goes from 0 to 5, since we're trying to integrate from 0 to 5. I hope everything is clear from this video. I have some other videos, other tutorials on numerical methods, such as the trapezoid rule, the fixed point iteration, false position, and other rules. So if you're interested, please take a look at those as well. Thank you for watching.